Okay, hi, good afternoon everybody. Welcome to another episode of Math with Thinker's Cap. Okay, my name is Mr. Tam. Okay, in today's lesson, okay, we're going to talk about how to prove a trigonometry identity. Alright, and this topic is usually taught in Sec 3 A Math, alright, where these type of questions, right, will feature, okay, in the topic on trigonometry. Okay, so in this particular question, okay, we will deal with basic identities, okay, where my angle involved is just theta, right? Okay, so let's take a look at this identity here, where we are asked to prove that the left hand side is equals to the right hand side. Okay, so in proving an identity, we all know that an identity is true for all values of theta. So we cannot just substitute a value of theta, okay, to just prove that left hand side is equals to right hand side. Alright, so in this case, we will follow two guidelines, right, when proving an identity. The first guideline is we're going to start from the more complicated side, okay, and to simplify, okay, towards our target side, okay, which is the more simplified side. Okay, in the second guideline is we're going to make use of identities, all right, to help us perform that transformation. All right, okay, let's start from this question, right? So in this case, I have got a perfect square here, okay, and a fraction here. Right, so most students will tend to start from the left hand side because the left hand side is actually a perfect square which I can do expansion. Okay, whereas for a fraction it is not so easy to transform from a fraction to a non-fraction. Alright, so let's start from the left hand side in this case. Alright, and I have cotangent theta plus cosecant theta bracket square. And in this case, this is a perfect square, so I'm going to use my expansion. My a plus b bracket square is a square plus 2ab plus b square. Alright, so I have got cotangent square plus 2 cotangent theta cosecant theta plus cosecant square theta. Alright, so if you look at our target, okay, our target consists of just the constant and cosine. Okay, so there's no cotangent involved. So I'm going to find a way to transform, okay, my cotangent into cosine and sine. Okay, so in this case, I'm going to do the next step where I'm going to transform my cotangent into cosine square theta over sine square theta. That will be my cotangent square theta plus 2 cosine theta over sine theta. That's my cotangent theta. And my cosecant theta is actually 1 over sine theta, right, plus 1 over sine square theta. Alright, so in this case you realize I've got 3 fractions here. Okay, my target is fraction, so we are in the right direction. And if you also realize that the denominator for these 3 fractions are actually the same, sine square theta. Right, so in this case I can combine the 3 fractions together with a common denominator of sine square theta, and I've got cosine square theta plus 2 cosine theta plus 1, okay, which is the numerator. Right, so again looking at my target, alright, cosine square theta plus 2 cosine theta plus 1, okay, is actually a factorizable quadratic expression in terms of cosine theta, alright, but my sine square theta, okay, does not feature in the target because my target only has cosine theta. So again, I've got to make use of an identity, right, to transform my sine square theta into something that is related to cosine. So in this case, I'm going to make use of the first identity, right, my sine square theta plus cosine square theta equals to 1. Right, so in this case, I'm going to do this. Okay, cosine square theta plus 2 cosine theta plus 1 over 1 minus cosine square theta. Okay, and the next step, I'm going to do factorization. Alright, so this numerator is actually a perfect square. So this is actually cosine theta plus 1 square over, okay, 1 minus cosine square theta. Okay, if you can recognize, this is actually the difference of 2 squares. 1 is actually 1 square. Alright, so we can make use of the factorization, right, for difference of squares, the third one, right? Okay, and we can do 1 minus cosine theta times 1 plus cosine theta. Okay, up to this stage, right, you will realize that my numerator and my denominator has a factor that is common, right, which is cosine theta plus 1, right? So I'm going to cancel one of them, all right, and that will result in, okay, cosine theta plus 1 I'm going to rewrite as 1 plus cosine theta over 1 minus cosine theta, right? And that is exactly the same as my right hand side. Proved, right? So this is how we prove an identity, starting from one side of the identity through simplifying, through factorization and expansion, and possibly, okay, applying the identities here, working towards the target, okay, of my right hand side, and thus proving the identity. Right, so if you find this lesson useful, okay, please feel free to share it with your friends, okay, and I look forward to seeing you in my next lesson. Thank you.